All right, let me just move my camera. Because now it's just in a weird old spot. Beep, beep. There we go. And my notes. Went on my walk, I wasn't prepared. All right, beautiful. So we'll just look at a few things with synthetic division, and then whatever questions you guys have, I'm more than happy to answer. But if nothing else, you just kind of organize your stuff for tomorrow, and you should be good. Okay, trying to figure out my space in here. I'll start right there. Okay, let me say determine weather. Oops, if I could spell the word weather, that would be good. I just even write. Sorry. Weather, there we go. X plus 2 is a factor of 3x to the 5th plus 12x to the 4th plus 11x to the 3rd minus 28x minus 96. We couldn't make it easy. I didn't answer the first one, but there you go. So I'm grabbing my calculator for this one too. So to determine if something is a factor, we're going to divide it by, or divide those two things. And if the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. So just as a reminder about synthetic division, because I don't want to use long division. I don't have to. If this is x plus 2, remember you find the 0, that would be negative 2. And then over here I'm using my coefficients. Just make sure you're going down in order. If anything is skipped, you do put a 0. So we have 3 for x to the 5th, 12 for x to the 4th, 11 for x to the 3rd. There is no x squared. So even if you want to just like make a little note to yourself, 0x squared. Negative 28x, negative 96. Once you do the setup though, the steps aren't bad. So you just kind of repeat the same step. You bring the first turn down. And then you do a little zigzag. Negative 2 times 3 is negative 6. And then we're always adding those. That will be 6. Negative 2 times 6 is negative 12. Add those, so I get negative 1. Negative 2 times negative 1 is 2. Add those, you get 2. So once you do it, it's kind of quick. Just following those same steps. Negative 2 times 2 is negative 4. That would give me what? Negative 32. Negative. Yeah, I was going to say that's not the same thing. That would give me 64, which would be 32, or negative 34, excuse me. I can say it right now. Huh?
Right, it'd be negative 300.
That's what you know what? In my head, I said negative 32, and then I put
say negative 32 out loud.
And then I put in, I don't know what I did. Life, guys. It's a miracle life. So if it asks if it's a factor, I could actually just say no right now. If it just said divide it, just as a reminder of what the actual answer is for division, if this is x to the 5th, then you take 1 less than that. That's x to the 4th plus x to the 3rd minus x squared plus x. That's our constant, and that's our remainder. So we would say this is not a factor, or x plus 2 is not a factor. If it said y, you would just say because the remainder is not 0. And then just a few other things. Once again, synthetic division, you kind of do a lot, but sometimes it just asks you things in different ways. If it had said something like this is p of x, find p of negative 2. That's what we just did, but just as a reminder of what this means, that's a remainder theorem. If it says find p of negative 2, whatever your remainder is would be your answer. So same problem, it's just a different question being asked. So instead of us having to do all that work out again. So once again, just focusing on what question is actually being asked at that part. And take that bad boy out. Oh, I want to do the next one. Okay. So I have a few that I definitely want to do with you, because I know you'll see them. All right, so the next one, I'm gonna give you a polynomial. Sorry, I'm just trying to not rush people, in case you're still writing. So we've got a good old polynomial. I'm gonna say the polynomial is p of x. We use that notation a lot. It's a function, but it's a polynomial, so we use p. And it's 6x to the 4th minus 23x to the 3rd minus 14x squared plus 97x. Oops, 97x. That's good. I like to say things and not write them. Minus 30. I'll erase my work here. And I'm going to tell you, p of x has two factors. X minus 3 and x plus 2. So I know two factors. Technically, remember, since this is to the 4th factor, it should have four actual factors. But we know two of them. I'm going to say factor completely. So what you would do in this case, because if I asked you to factor this, we'd be like, I don't know what the heck we're doing here. We just have a big long quartic polynomial with 5 terms. There's too much stuff. But once it tells us some of the factors, what we can do is divide those factors out so then we can get a polynomial that's easier to deal with. So let's start with the first factor. We're going to do synthetic division. So we're going to take the orig. We'll divide it by x minus 3, which remember you put a 3 there, just as a heads up. And then I'm just going to use my coefficients, 6, negative 23, negative 14, 97, negative 30. And let's see what we get. Bring that bad boy down, we get 6, and then we just kind of do our quick little steps here. That's 18. Add them together is negative 5. That's negative 15. Add those together is negative 29. 3 times negative 29, I have no clue. Negative 87, let's use a calculator. That gives me 10. And then we get 30. And it makes sense that the remainder is 0 because it did tell us that this was a factor. So just make sure like your work makes sense as you do it. So think about what that means. It means this is now, since that was quartic, this is now cubic. So that's x to the 3rd, x squared, x plus 10, remainder 0, I don't really care about, but you know, at least it was a good check to see that it was a factor. Now, it asked us to factor completely. I still don't really want to factor this. Yeah, it's not going to work though, right? Because the things wouldn't match, it would be a big mess. So if you know another factor, you just take this and divide it by the other factor, then it'll keep breaking our polynomial down for us, and then it will be way easier for us to find the nice answer. So we're going to take this answer and set up another synthetic division with the other factor. So that would be 6, negative 5, negative 29, 10. Once again, you could have tried factor by grouping, but it's not going to work because your groups won't. It'll just be a big old mess. So bring that down. Do your little nice little steps here. Negative 12, that gives me negative 17. That's going to give me 34, which is 5. That's going to give me negative 10, which is 0, which makes sense because it's a factor. The remainder should be 0. Once again, we do all this dividing if we know the factors are there to make our polynomials easier to deal with. So this would be x squared minus 17x plus 5. So now that I'm down to here, I'm saying, well, it's asking us to factor completely. I can factor this, right? This is easy. Good old quadratic trinomial. Going back to the basics here. If I factor 6x squared minus 17x plus 5, what do I get? 3x minus 1, 2x minus 5. Thank you. Beautiful. Now remember, always answer complete or like answer the actual question. The question says factor this completely. So if I said, what was the factor form, you would say x minus 3, x plus 2, 3x minus 1, 2x minus 5. What a beauty. So you put everything together, right? If I said something like, hey, what are the zeros? You just do one extra step. The zeros would be 3, -2, 1/3, and 5/2. So just read the question. All stuff we've kind of dealt with, but it's just putting everything together. But just as a heads up, if you're ever given two factors, you kind of just synthetically divide out one at a time. So we took our original polynomial, picked one, divided it out. Then we got that smaller polynomial. We divide the second one out, and then it gets us to a place that we can actually just factor it. Life is a little bit easier. All right, so I'm going to give you the same type of question, just once again, same thing, just like worded a little differently. I just want to go over the wording with you, but then I'm going to have you guys actually do the math out. But as of right now, are there any questions with what we've seen so far? So hot in here. Okie dokie. Which one am I giving to you? So given a polynomial, P of x, it's going to equal 8x to the fourth minus 10x to the third minus 29x squared plus 19x, I can't even read, plus 30. Okay, what a beauty. Okay. So it's just giving me a polynomial. That's exciting. It's kind of just what you start with. And then it's going to tell you the same stuff, just in a different way. So we just want to look at that. I'm going to ask you to write it in factor form. That's what we just did. So that's looking semi-familiar to us. Form given that P of 2 equals 0 and that P of -1 equals 0. Same exact information, just written in a different way. So remember, this is called remainder theorem when we see something like this. It just means in my polynomial, if I divide it by 2, I have a remainder of 0. That means 2 is a factor. That's all this is saying. So sometimes we just write things fancily. So just remind yourself, because remember, tomorrow's a notebook quiz. This is just saying 2 is a factor of P of x, because the remainder is 0. And then it's also telling me that -1 is a factor of P of x, because with remainder theorem, the remainder would be 0, which means it's a factor. So now I'm going to have you do kind of what we just did. Can you take your polynomial, pick one, it doesn't matter which one you do first, so it's just a preference thing. So pick one of these zeros, divide it, and then once you get your new polynomial, then pick the other 0, divide it, and then see can you factor any more. Fun stuff. So as you're doing that, I'm just going to take attendance. But if you see something in the meantime, if you have a question on you, let me know. It's all dirty here. I'm going to turn on my other computer. So. Attendo. We got minute to do these. I actually don't even know if tomorrow you have to do one with 2. It's just one of those things that's gonna pop up now and then, so there's no harm in practicing. But I'll give you a better idea of kind of what you need for that little notebook quiz in a second.
Oh my goodness, the correlation coefficient is the same. I changed that from watch. And it's the same. It is the same relationship. Is not changed by shifting or scaling. If I added 75 minutes to each of those observations,
Opening the window is just too nice to know. Fresh air home to the
what I did originally said here. First, you know what? I'm going to put some what happens. I have a new one.
About 30 more seconds, we'll kind of get started and then we can check in with each other. In a moment, I'm also going to ask you, once it's in factor form, identify all the zeros. So, do that. Once again, does it make it harder? No. It's just kind of an extra step, so always just read your directions and what it's asking for. So sometimes it will just ask for factor form, sometimes it'll ask for zeros. Just depends on the problemo. Alright. If I did use my marker, here we go. Oh, we are fabulous on time right now. So we're happy. Alright, so let's get started. I'll kind of start up here. I'm going to start. Remember, if it says P of 2 equals 0, you're just using 2, okay? Don't change the sign. You only change the sign if it says like something like x minus 2. So that's just telling me the 0 is 2. I'm going to throw 2. I'm going to use my coefficients. Oh gosh, what do we got? 8, negative 10, negative 29, 19, and 30. And I'm going to do my thing here. So that gives me 8 is 16 is 6. Is 12 is negative 17, is negative 34, negative 15 is negative 30 is 0. So just little things like make sure the remainder is 0. And if it's a factor, that should make sense. And then I just like to rewrite it. X to the third plus x squared, that's an x, that's a constant, that's a remainder. But from here, I'm just kind of doing the same thing. I'm just using these coefficients. I'm going to do a second step because there was a second factor, divided by negative 1. Once again, I don't need to use the 0 there, so we just kind of go. So what do we get? 8, negative 8. Sorry, my arm's killing me. Negative 2 is negative 15. Is 15 is 0, which makes sense because it's a factor. So that's 8 squared, x, cha-cha-cha. So now we're going to take that and factor it. What's that factor to? 4x plus 5, 2x minus 3. And if I want the complete factored form, I would take those factors but add the other factors that I know. Once again, if the factor is 2, we would write it as x minus 2, and the other one was 1, so that would be x plus 1. And then once again, if I said, hey, what are the zeros of this? You would say the zeros are at, yeah, you can kind of go in whatever order, negative 5/4, 3 over 2, 2, that was an awkward 2, and negative 1. You get the idea. Fabulous. Okay, I want to show you one more thing, I think. Just in case. This does pop up tomorrow, so basically one more problem, and then I'll go through what you need for tomorrow. If we have time, we might do one other thing. We'll see. We'll see. Oh, getting outside made me feel better. So happy about that. All right. So kind of last one before we just like remind ourselves what we need for tomorrow. So we're going to be given a polynomial. There we go. Why are they always so gosh darn hard? But here we go. Sometimes you need to make them long just to, so they're factorable. I'll erase that in a second just in case you still need it. And I'm going to say, given that x equals 2 is a factor of p of x, find all other zeros. Okay, so I'm like, I know a factor. Basically, like you've noticed, pretty much every time you know a factor, you're just going to divide it out, see what's left. What else can you do? So once again, if the factor is x equals 2, so you just put a 2 here, right? It tells us that. I take my coefficients 3, negative 13, 5, and negative 30. And I'm going to have to do my thing with synthetic division. But now that we're getting used to it, like synthetic division, it's kind of delightful, right? It's kind of quick. You don't have to like think too much about it. It's the same steps every time. You just throw stuff in. So what do we get? 6 is 9, is 18, is 5, is 10, is 50, is 30, is 0, which makes sense because it is a factor. And that was all that was given to us. So we're going to say, okay, well, what are we left with? So this would be 3x to the third plus 9x squared plus 5x plus 15. Once again, I don't really need the remainder because it's 0. Whereas before we'd be like, oh, we have another factor, we can plug it in. We don't have another one. So at this point we would, Kevin brought it up before, we would factor by grouping. So if you don't have anything else left, you just say, if it asks me to find the zeros, I'm going to have to kind of keep going. Can I factor this? Yes, I can. By grouping, I will make 2 groups. I will take the GCF out of each group. Excuse me. I'm going to write it over here just in my factor form. It would end up being 3x squared plus 5, x plus 3. We're finding the zeros. Okay, so that wasn't terrible. The last one we had done, what you couldn't factor by grouping, but it had given us another factor. So that's why that one worked out. So let's solve these now, because remember, as we're solving, not everything has to be real. We're going to have an imaginary answer, and that is perfectly fine. So in this case, I'm going to subtract 5. I'm going to divide by 3. I'm going to take the square root. We don't leave it like that. No way. I'm going to kind of do I still got a little room over here. Okay. This one I can do quick, sorry. I'm still going to do the workout for that. I just kind of ran out of room there, so I'll do it right here. Just as a reminder, if you have the square root of a fraction, you split it up to the square root of the top over the square root of the bottom. And then you rationalize your denominator. My God, there's so many steps to this one. Oops, the negative is underneath, Mrs. Sherman. Don't do that. And then we know negative underneath a radical, we put an I on the outside. So all that work, since we took the square root, we put a plus minus. Holy bajoli here. And that's right. So just as a reminder for tomorrow, if I asked you, how many roots does this have? You would say 4. Okay, so there's going to be 4 roots because it's to the 4th power. That's the degree. Do we have 4 roots? Yeah, we do, because one of them is 2. One of them is 3. And then plus or minus I root 15 over 3 of the other 2. So we do have 4 roots. If I graphed this, how many x-intercepts would it have? So we have roots at 2, -3, sorry, my negatives mixed in with the equal sign. And plus or minus I root 15 over 3. So we have 4 roots. How many x-intercepts would I have if I looked at that graph?
I don't remember.
Someone just say a number, make me feel better about myself.
2,
The answer is 2. Why is the answer 2?
because 2 answers aren't real.
Exactly. So when I'm graphing, I can only see like real numbers, right? I can't see imaginary numbers, they're imaginary. So the imaginary numbers kind of affected like the turning points, but you don't actually go through the axis at that point. So if I were to graph this, I could see it would pass at 2 and it would pass at -3. I wouldn't see these though on the graph. So just as a reminder of like the differences, and once again, just like little wording, it has 4 roots. But if I ask how many intercepts it has, if I was actually looking at the graph, you would only say 2 because there's only 2 real answers. Okay. So playing along. All right, so there's a few other little things, but they're not on the quiz. So if we have time, we can get to them. If not, we can do them on Monday. So let me just do a little check ski here for you guys. Just give you a general idea, like what do you need? If there's anything you have a question on, you let me know. So the main goal for tomorrow, one for everyone, we're gonna come in. We'll take our mass break at the beginning. We'll just kind of go all quick. Once again, I'm just trying to make it even across the board because if you guys got 10 less minutes than my other class, you'd be all up in arms about it. So I'm trying to make it even for my blocks.